Hi, my name's Ted Aranda, and I'm with the Revolutionary Alliance for Truth and Democracy. Our website is raftd.org. This video is on the Apollo moon landing hoax. I've done a couple of presentations on this topic at the College of Complexes here in Chicago. In fact, I've done a number of presentations on various false flags, hoaxes, and other huge deceptions by the U.S. government. The general theme has been USA, Empire of Deception, Tyranny of Lies. My overall goal politically is achieving democracy in this country. But evidently, conventional issues, and these here are obviously groups of issues, like economic oppression, imperialist war, environmental destruction, have not been sufficient to spur the people to do what we really need to do, which is to undertake democratic revolution. The populace apparently needs a much bigger shock than ordinary issues, no matter how important they are, can provide. Learning that the government is the perpetrator of the greatest criminal deceptions in the nation's history might finally awaken the people to the imperative need for total system change. The Apollo moon landing hoax fits squarely in this category of massive deception and crimes. Effective investigation of most false flags and hoaxes requires open-mindedness, diligent research, and logical and scientific thinking. In other words, common sense more than professional expertise. However, in this case, that is Apollo, my experience as an advanced amateur astronomer has been very helpful. Now, as for Apollo, these were without question fake. Criminal deceptions by the government of this magnitude are utterly unacceptable, to say the least, and the American people must respond to them appropriately. This requires that we know with certainty what's going on with these events, what our rulers are doing. And we can know this by examining the evidence, carefully, objectively, and scientifically. Here's what a couple investigators say. Bart Zabrell: I'm absolutely convinced. I'd bet my life on it that we didn't go to the moon. I know for a fact that we didn't. Dennis Semino says, it's absolutely certain. Not probable, but certain. I'm not 99.9% certain. I'm 100% certain. All of the evidence proves we never went. It was a very elaborate hoax. This is the quote-unquote table of contents, if videos had table of contents. And I'm not going to go through all of this because I hate long introductions, and I'm going to talk about it also why I talk about it now. But you can look it over, you can pause and look it over. I just want to point out where these asterisks are. These are subtopics that I'm covering here, either for the first time or much more deeply than ever before. So this would be new material for anybody who might already be somewhat familiar with this subject. So I'm going to start off with this famous photograph, one of the most iconic photographs in the 20th century. There are three things in this photograph that prove fakery, that this didn't happen on the moon. So notice where this horizon goes across in relationship to the astronaut. It goes across his face. And that is impossible, because the astronauts had their cameras always at their chest, like Neil Armstrong does there. That's in the visor of Buzz Aldrin. This is Buzz Aldrin. And the astronauts always had their cameras at their chest. As a matter of fact, there was a bracket there on their spacesuit to hold the camera. And notice where the horizon is here in these frames from a film. It's at their chest, where the camera is. And that's how it has to be when two astronauts, or two people, are standing just a few feet away from each other with their cameras at chest level and taking pictures of each other. The horizon has to be at their chest. It's a very basic problem of geometry, and it's a fact. So you see this astronaut in this guy's visor? He has his camera at his chest. Okay, this is how it should be. Okay, this is when they did it correctly. The photo that I started with, that famous photo, it was done incorrectly. Here is a photograph I took of myself, and to do this, I put a camera on a tripod and I put it at my chest. Okay, the camera at my chest. This is another photograph I took, and here, oh, by the way, did I mention, in this photograph, the horizon is at my chest. That was the first photograph I took. In this photograph, I made it so that the horizon was at my face. And to do that, I had to raise the camera by over a foot, and I had to put the tripod on this stand. okay? And so there's the camera now. That's a big difference, a very big difference in relationship to the height of a person. You can't dismiss that. When two people are standing on reasonably level ground, and there are some pits there, but that's not significant. That's just a matter of inches, not feet. When the terrain is reasonably level and two people are standing close to each other and they're of about the same height, which Armstrong and Aldrin were, you have to have the camera the horizon at chest level, where the cameras are. So they got it right sometimes, like here. They got it wrong other times, like the famous photograph. And here's another case where they got it wrong. So what's going on here? What's going on is pretty simple, actually. This photograph was not taken on the moon. It was taken on a moon set here on Earth. And probably for all these photographs that we're going to be looking at that are allegedly from the moon, all of these photographs were probably taken by professional photographers, not astronauts at all. The people inside these suits may not have been astronauts all the time. That could be the case. So they made mistakes, like here. And so this photographer in this case undoubtedly put the camera up to his face because he was taking a normal photograph in the normal way. He forgot to put the camera down take the picture from a position which is equivalent to chest height. So that's what happens when you're faking things. You get it right sometimes, you get it wrong sometimes. Reality is just what it is. It's not right or wrong, it's just the way it is. You don't make mistakes in reality. Or you do, but that's another story. And the Apollo program was very long. It was about 4 years long. The landings, the part of it with the landings was about 4 years long. It was a huge, complex project, and you make mistakes when you're faking things so complicated. Okay, let's move on to the second problem with this photograph, and that is that the astronaut is clearly standing under a spotlight, and the ground is very unevenly lit. So this is impossible for two reasons. One, the astronauts didn't take any huge lights, floodlights, spotlights, any large lamps to the moon. And as NASA says so itself. All the outdoor lighting was supposed to be by sunlight. Secondly, on the moon, there is no such uneven lighting at all, except for maybe right at sunrise or sunset. And here you see the indications of a fall-off area. That is a photographic term when you have a spotlight and then you have the darkened area around the spotlight. There is no dusk or dawn or twilight on the moon of any significant duration, only day or night, because of the lack of an atmosphere. The sun is either in the sky or it is not. Therefore, the landscape is either brightly lit or it is black. Ground illumination by the sun anywhere is even or uniform, assuming reasonably level, homogeneous terrain. No large lamps were taken to the moon to provide extra lighting, and NASA affirms this. So for these reasons, what we're seeing here is not on the moon. This is not a photograph taken on the moon. They corrected this problem. That original photograph was from Apollo 11. This is later missions, so they corrected that problem. This is how the lighting of the ground should be. It should be completely even. Just like it's even around me here and around my telescope out there in the desert. There is no concentration of light, and there would be no reason for any such concentration of light. Here are a couple more photographs from Apollo 11, and you can see the spotlight effect, especially in this photograph. It's very clear. So what we're seeing, without doubt, is lighting by spotlight, a floodlight of some sort. Maybe not necessarily quite that focused, but a floodlight nonetheless. Artificial lighting, in other words. And here is a soccer field lit by natural sunlight, and as you can see, there's no concentration of light anywhere. Here is a soccer field at night, and there's obvious fall-off area around the field and even inside the field, because the illumination is not going to be even with floodlights across a very large area. Natural sunlight, even through clouds, The sunlight diffuses the light, and it's all around. Here the fields are lit, and of course they don't want to light up the entire neighborhood, so clear-cut fall off around the field. The third problem with this photograph, and we're talking about major problems, there are probably other problems that some other investigators have seen as well, but the third huge problem with this photograph is that this astronaut should be completely black, okay? At least extremely dark, if not literally completely black. And that's because on the moon there is no atmosphere to diffuse the light, which is what causes what would be dark shadows on the Earth to be reasonably well lit. So here you can see how well lit he is. If that were writing and you could focus, and the photograph was better focused, you would be able to read it. Everything is perfectly well seen. That would be impossible on the moon. All shadowed surfaces on the moon are extremely dark, pretty much black, since unlike on Earth, there is no atmosphere to scatter, diffuse, and spread the sun's rays and thereby illuminate surfaces not in direct sunlight. Light-dark contrast is extreme and severe. It is the moon's total lack of an atmosphere that renders its surface so sharp and clear to our view that we can see minute detail on it all the way from Earth. So this is an amateur photograph, and we're going to rely mainly on amateur photographs because you can't trust most Apollo photographs, NASA photographs. And you can see how inside the shadowed areas, it's completely black. And this is how all photographs, properly exposed photographs of the moon are. Like inside that crater, it is pitch black. Here's a well-lit side of a crater in sunlight, and here on the shadowed side, it's black. Same thing with this mountain, this central peak, well lit on the sun side, black on the shadowed side. And here's another central mountain. This is actually from Copernicus. Same thing, black shadows. The Earth is a different story. You have shadowed surfaces which are quite well seen. This peak is casting this shadow, and you can see inside there. This is a low light situation, probably near dusk or dawn, and still you can see inside there. And if you were standing in there, of course you would see things. You wouldn't have trouble seeing anything in there. This is a special case. This is Meteor Crater in Arizona, also known as Barringer Crater. It's the best preserved large crater, a meteorite crater on Earth. So it looks very much like how moon craters in general look. And you can see right into it even with the shadow. And here's a man standing in front of Meteor Crater, and you can see his shadowed side for the same exact reason that you can see the crater's shadowed side. It's because of the atmosphere scattering light. The correct definition of daylight is sun-illuminated atmosphere. On the moon, there is no such sun-illuminated atmosphere. So if you had an astronaut standing here and you were photographing him, let's say you were on this side, on the right side, and you were photographing this astronaut standing on the rim of that crater, like this guy is standing there, okay? And you took his photograph with this side of the crater in the background. This would be black, just like it looks right there. And the astronaut himself would be black for the same reason, that they're not receiving direct sunlight. The astronaut would not look like this. He would be black. Now there is a special case on Earth where you have very dark shadowed surfaces, and that is in low light silhouette situations. In fact, it's a genre in photography called contre-jour, and it can be a desired effect. But let's say you wanted to light up these shadowed subjects, okay? What would you do, or what would you have to do? You'd have to overexpose it. That would be one option. Overexpose the photograph. And then you would see how dark it is under this porch and inside that window. Well, you can light it up by overexposing the photograph. Okay, but of course that would ruin the overall picture, so you wouldn't want to do that. But there's another option, and that's using low light flash fill. So here you have a woman in a silhouette situation, she would normally be dark, her shadow would be dark, but here she has no shadow, and that's because the photographer is using the flash on his camera. Another term for this is fill flash with backlight. The key is backlight. So here he is photographing this woman and into the sun, and here's what you get. You get a dark subject. So what does he do? He uses his flash on his camera. You can see how it lights her up right there. And lo and behold, you have a well-lit subject even in what would normally be a silhouette situation. On the moon, or rather, in the Apollo photographs where they're allegedly on the moon, you have clear-cut silhouette situations. This is supposed to be the sun, but of course it's not. It's just a bright spotlight. And this photograph is probably taken indoors. It's undoubtedly a moonset. It's probably an indoor moonset, which would normally be dark, except for that light. Okay, and this is a silhouette situation. This should be dark. This should be quite dark. And here, this is Apollo 11. This is Buzz Aldrin climbing down from the LEM, allegedly. Okay, he should look dark, at least as dark as that woman there. If he were on the moon, he would be completely black. But even in an Earth studio, in this situation, in an indoor studio with that light, with that bright light, he should be dark, just at least as dark as that woman there. So here he is, inside, still inside the cabin of the LEM, inside and on the shadow side of the LEM, and you can see clear as day. And there again, here he's climbing down. And notice here his boot. There's a hot spot. That's a photographic term, a hot spot on his boot. That indicates a specific, definite source of light, secondary light, apart from the alleged sun being used to illuminate the shadowed side. And here he is again, and again, look at the boots, hot spots. Okay. So a secondary source of light was certainly being used. And here's another case where the astronaut should be dark. If he were on the moon, he'd be black. Even in an indoor studio with the light up there being the only source of light, he should be pretty dark, even on Earth. But he's well lit, and that indicates that a secondary source of light is being used as backlight. And this is an animation to show how the astronaut would look if he were really on the moon. He would be black, and so would the moon rover, by the way, that side of the moon rover. There you see the difference. These are not isolated cases or instances. This happens again and again, where you have clear-cut silhouette situations. There's no way in the world that this should be or would be so well lit if this were on the moon. So what they did was they flashed or they used some lighting, okay, to light up the shadowed side. It's that simple. That's what they did. And notice that when you do that, you don't illuminate the ground very much. Okay, the ground is relatively unaffected. In this photograph, this original photograph again, you can see evidence of secondary lighting, and you can tell that from the dark surfaces in this photograph on the shadowed side of that astronaut, on top of his helmet, on the top of his backpack, and the top of his shoulder. Why would that be? Why would you have that differentiation in the lighting between those surfaces and the vertical surfaces? In reality, if you were on the moon, he would be dark, and he would be uniformly dark. And even on Earth, in a studio, with that light up there as the only source of light, he should still be uniformly dark. This difference in the lighting of horizontal and vertical surfaces, he's well lit on vertical surfaces, that indicates a secondary source of light being used. Now this here is a beautiful case showing the necessity of backlight, secondary lighting, to illuminate shadows on the moon. The absolute necessity. what this photographer did was he took a well-exposed photograph of Tycho. This is Tycho crater here. Okay, and then he deliberately overexposed the photograph, so to light up the inside of Tycho, which he succeeded in doing. That's the original, or the first photograph he took, I should say, and then the overexposed one. So he wanted specifically to light up the inside of Tycho, and he did. But what did that require? It required a huge amount of backlight. Tycho is 53 miles in diameter, 53 miles across, and that crater rim provided an enormous amount of backlight. So lighting up the inside of Tycho crater took three exceptional conditions. One, the overexposure of the photograph. Two, a huge amount of backlight, sunlight reflected off a 53-mile diameter rim. And three, a relatively young crater with a well-sculpted vertical rim, which is what Tycho had. Now, look at the other craters near Tycho, which are almost as big, okay, but they don't have that nice rim on the sunlit side, okay, it's like Tycho does. So you don't have a whole lot of backlight, and they're dark inside, they're black inside. And same thing with these small craters here. Now, interestingly, these craters, these small craters here, are young craters with nicely sculpted rims, okay, that reflect a whole lot of light, and they're lighter inside. And these, by the way, are also very large. They're not as large as Tycho, but we're talking something like on the order of 10 miles across. So that's what it takes to light up craters on the moon, and any shadows on the moon, is a huge amount of backlight. And even that wouldn't have been enough. The photograph had to be overexposed. So this is a properly exposed photograph, and there is no huge amount of secondary light. If it was on the moon, there would not have been any huge amount of backlight, and so the astronaut would have been black. Now, we might ask, didn't the Apollo scientists know how things should look on the moon so that they, would represent it that way? And the answer is possibly. Sometimes they may have simply overlooked things, made mistakes, but they may have known, actually. But that is not their goal. Reality was not their goal. They were producing a show. Aesthetics trumped accuracy. And for sure, propaganda was the aim, not truth. So the so-called astronauts were not actually on the moon. Where were they? They were on a moon set, and there are a few possibilities. Or not just possibilities, these are facilities that were used either for practice, training, or for hoaxing. This is a photograph of the moon, right? Craters on the moon. Actually, no. This is a field in Arizona. I was flabbergasted when I learned that myself. And this is the same field, but here you can see the tire tracks. And this is field number 2. This field right here. One of 2 fields in Cinder Lake, Arizona. This is written wrong. There's no S, and it's near Flagstaff, but the place is Cinder Lake. And this is field number 1. Again, this is field number 2. This is a close-up of field number 1. And here you see the trees in the background and bushes. Okay? Definitely the Southwest American desert. So here's the location, a little 12 miles actually northeast of Flagstaff, Arizona. There they are again, and here's an aerial view of field number 2. You can start to see some of the craters there. And what this is an ancient basalt field. It's from an ancient volcano. Here's a little closer up. And what they did was they cleaned up this field. Was already rather barren to begin with, undoubtedly. But they cleaned it up even more, which I'll show you in a second. This is the material, the basalt. So in this film, in this little short film, this 9-minute film or so, it shows how they made this field. And so they cleaned it up because it wouldn't do to have, bushes on a moon set, anything, terrestrial. And they blasted the craters literally out of the ground. And this is the result, and it's pretty realistic. These are aerial photographs. And this is actually an aerial photograph of one of those fields. And this is an astronaut, I don't know which one, during training, running around these craters. And same here with something representing the moon buggy, the moon rover, the lunar rover. And you can visit these fields even today, and this gives you an idea of how large an area they had to play with. So some of those stage sets that we're going to see were rather large. You know, we're not talking about literally a little stage set in a theater. We're talking about fields. Now, another moon set, so to speak, is the Langley Research Center in Hampton, Virginia. This place is like a university campus. And notice this structure right here. I'm going to get to it in a second. And it's so large they actually need a map to get around. And as it says here, there are over 200 facilities on the center. And this is the structure that I just pointed out, and it's called a gantry. Notice the cars down here. That gives you a feel for the scale of this thing. It's huge. And it's used to raise and lower objects, any object, but here we see the lunar module, a model of the lunar module being raised or lowered, and here a so-called astronaut onto a field that this one doesn't look very much like the moon, but you could certainly make it look like the moon. So they had that to play with. They also had huge moon globes, which they made very carefully, and wall charts that they illustrated to look, you know, just like the moon. And here's one, a wall chart and a globe. And notice this rail track here. So they could use that to simulate approaching it or leaving the moon or orbiting the moon. And in this book, it's shown on a wider scale how you could use these facilities. And this is one of the reasons that so many of the moon photographs taken from the spacecraft are so funky and so in such poor quality, because they weren't actually of the moon. They were of illustrations of the moon, and no matter how carefully you make them, they're not going to look quite real. And also, NASA wouldn't have wanted it to look very close-up views in perfect sharpness, because then the fakery would be even more obvious. This is what they were doing. They were photographing models of the moon, not the moon. Another moon set is in Mercury, Nevada, in or near Mercury, Nevada, which is part of the Nevada test site, actually. And this is all military restricted territory. That's Las Vegas right there. Use of deadly force authorized. These are photographs from Bill Kaysing's book, We Never Went to the Moon, which is an excellent book, one of the first books, actually the first major book on the Apollo moon landing hoax. And it shows photographs, as I said, of Mercury or around Mercury. There were numerous facilities there, top secret facilities. So, any way you slice it, NASA had moon sets, literally where they staged the moon landings and carrying on the moon. The only question is whether that was just training for going to the moon or if it was the entire thing. And clearly, as I will prove beyond doubt by the end of this presentation, this was all it was. They were never on the moon. Okay, more evidence. I already showed you 3 pieces of evidence from that iconic photograph that I began with, and here's more. As it says here on this photograph, every Apollo photo contains this unnatural separation line. Let us refer to it as the Kubrick horizontal. And what this is literally a line, a sharp line separating the foreground from the background wherever there's something in the background, like this fake mountain. Many of the photographs, in fact the majority, would have just a black sky, but wherever you have a distant background with things in it, you have this separation line, okay? And it is totally unreal, and it's ubiquitous. There's only one exception in all the hundreds, if not thousands of photographs I've seen, and I'll show you that in a second. What you'll notice is the great amount of detail in the foreground, which is clearly real. You know, there's no question that this here is not totally made up. But what it is it's a stage set. It's a real stage set. This, however, is simply a projection on a screen. It's totally unreal, the background. And a number of, or at least one commentator said that every Apollo photograph seems to have a field of 100 meters in width, and then nothing, and then it drops off, and then, you know, things change. And that's what you see in all these photographs here, is this stage set, which is limited. It's usually limited. As I said earlier, there are some photographs with a much larger field, but usually it's about this size. And then the fake mountains in the background. There's the cubic horizontal. And many times it's so blatant that it's absurd. As if, you know, I mean, different coloring and everything, okay? And so sharp. Now, this is the one exception that I mentioned. And here they succeeded, obviously took more trouble, put more effort into it. They blended the fake background with the foreground. But still, you have the detailed foreground and the totally washed out, bland, fake background. In real life, there is no such distinction, differentiation, certainly not such a sharp transition between foreground and background, at least not usually. Okay, and notice these people here to give you the scale of this scene. So here you have distant mountains, but they aren't totally washed out. You still have detail there. Why? You know, these guys had excellent cameras, so they took what should have been excellent photographs, but all their distant mountains are totally featureless, bland, mushy things. Okay. Anyway, so here the point is that there is no sharp distinction between foreground and background. Now, in these photographs from a panorama I took at my Nevada desert site, you'll see that eventually, as I pan, okay, we get to this point here where there is a sharp line. Okay, so it can happen in real life, but this is not the norm. This is in a specific place with this very particular geography. There's a dip beyond the end of this territory, this area here, okay? There's a dip, and it's in one direction. It's not all around. This is more the norm. This is the norm here. You have no sharp distinction between foreground and background. And you have detail showing in the background objects. Where you do see the sharp contrast between foreground and background is in this filmmaking technique called front screen projection. Okay, there's the stage set and the actors, and then on a screen in the background is a larger scene. This is a scene from Stanley Kubrick's 2001: A Space Odyssey, and this shows what's going on. There's a screen projected background and a foreground studio set. This is all there is in reality, a stage with actors in monkey suits actually, and the large screen for the projected background. And this is another scene from the same movie, and here the stage set is quite small in this particular scene, and then you have a larger background view which is totally imaginary, just projected. So here you have Apollo with the same sort of setup. An actor on a stage set, quite real, but only a stage set, not the surface of the moon, and then the projected screen background, or rather the projected background on the screen. And this illustration shows how it's done. You have a one-way mirror with the mirror on the opposite side. So here's the projector. It reflects the scene onto this specially reflective screen, and then the camera shoots through the glass, unreflected here, unreflective, I should say, unreflective, non-mirrored, okay, and this is what you see here. A real actor on a real stage set with a projected imaginary background. And this is a home setup showing in a little bit more clearly what's happening. You have the projector, the mirror, the special fabric screen, and the camera shooting through the glass. There's the mirror, the one-way mirror. More evidence of fakery. The infamous sea rock. In this scene, or photograph, there's something very, very strange, and it's right here. There's a sea on that rock. And stranger still, there's a sea on the ground right next to the rock. Perfectly formed seas. Now, to have one sea on just the rock or just the ground would be an extremely unlikely a coincidence that you have a perfectly formed Roman letter on a rock on an uninhabited moon, right? To have two of them together almost totally rules out any natural formation or any coincidence, which would be literally astronomical in its improbability. So what we're looking at here is really just a prop rock. And as this video said, the use of the letter C on film props is well known by Hollywood people and is used to show the center of the scene. Now, I couldn't actually confirm that, but certainly we're talking about prop rocks, which can be literally bought. I don't know where you would find them, but maybe not necessarily at your hardware store, but you can find them somewhere. And this one right here is about the right size for that previous scene that we saw. More blatant evidence: missing rover tracks. Alright, here are rover tracks on the moon where the rover goes. Wherever the rover goes, it leaves tracks because it's very soft soil, very fine soil, supposedly on the moon. So here you have tracks and footprints, and here you have tracks being laid by the lunar rover. Now, here's where the strangeness begins in relation to the rover tracks. There are none in this photograph. You can see footprints clearly, but there are no tracks between the tires, in front of the tires, behind the tires. How could that possibly be? This is the best resolution photograph, and you can clearly see that there are no tracks in front of or between, behind the tires. Okay. How could that possibly be? It can't, because you have to drive the rover to wherever it is on the moon at any given time. The only remote possibility is if, oh, and by the way, here's one more view. Actually, this is another photograph, and this is even more blatant. Here you have the footprints and more footprints, but no tracks. As I was saying, the only remote possibility is if the astronauts literally lifted the rover and set it down. All right, but why on earth would they do that? First of all, it was never reported that the rover broke down. Now, it would be possible for the astronauts to lift it because in 1/6 gravity, the rover wouldn't be particularly heavy. But again, why on earth would they do that? First of all, they never reported the rover. They never reported having done that. They never reported the rover having broken down, and all of this would have been, well recorded if that had been done. So that didn't happen. What really happened is pretty clear. The lunar rover was apparently lowered onto the stage set, probably from a crane, rather than driven to its location, as it would have had to be if it had been on the moon. And then the quote-unquote astronauts walked around it before it had been moved. So that was a mistake in the production. Another piece of evidence, and this one is, really damning. Large moving shadows. Here is one of the two astronauts on the surface of the moon at any given time. The third astronaut was orbiting in the command module. It's actually the command/service module, but it's usually just called the command module. But anyway, so a crew of 3 Apollo astronauts each time, 2 on the surface and 1 orbiting. There's the one astronaut, and a little further away is the second astronaut, and this is all being remotely filmed from a camera on the lunar rover. Now notice this fringe here, and here, these color fringes. That's called color banding, and that's a phenomenon in photography. It's not all that uncommon, and it occurs sometimes when objects and shadows move across the scene, and that's where that color is coming from, just so that you know, so you're not confused. Now, watch what happens here as the camera is focused on this distant astronaut. You have 2 shadows quickly passing in succession. Okay, I'll run it backwards. There's one, actually that was the second one, and there's the first, and with the color banding. All right, 2 shadows quickly pass across the entire scene, including that astronaut. And here it is in black and white. What could that possibly have been? There is nothing on the moon, living or not, that is moving. The only thing that would have been moving on the moon at that moment would have been those two astronauts, and as you can see, they're pretty still, okay, because whatever caused those shadows happened very quickly, because you can see that the astronauts aren't even moving. They're pretty much frozen. All right, there cannot be such shadows on the moon, since the two astronauts are the only moving objects there. There is nothing, quote unquote, flying in the moon's sky, except the orbiting command module, which, being so high and small across the face of the sun, would not cast a shadow at all, much less appear and in these shapes. Something clearly passed across the moon set's floodlight. And that's because they were in a studio on a moon set, not on the moon. And here is a real killer. We're running into, there are a lot of killers here. This one pretty much slays the Apollo mission. Let's look at some footage of spacecraft orbiting planets. Okay, this is the shuttles orbiting Earth. Okay, planetary objects. And these are 5-second intervals for each of these frames from this video. And you can see that things move very quickly. Okay, I should have actually done that more smoothly. Things move very quickly out of the field of view, and certainly out of the center of the field of view. Nothing stays put, okay? Because any spacecraft orbiting Earth or the moon would be moving literally thousands of miles an hour. This is allegedly a spacecraft, the Selene, I think it's the Selene Moon Explorer or whatever it's called, orbiting the moon. Now, I have serious doubts about the authenticity of this terrain. I think it's fake, but certainly the orbital motion is realistic. Okay, so let's go through that. Now watch that crater, big crater, coming from the top. I'll run through it one more time. Again, things are moving quickly out of the field of view. Even within the field of view, they're moving very quickly. Okay, and then finally, here's an Apollo 10. Here's footage from Apollo 10, which preceded Apollo 11. And here, things move out of the field literally in 2 or 3 frames. Within 3 frames, things are gone. You can hardly even keep track of them. All right, we're talking about just seconds, just a few seconds in the field of view for a particular object. Now this is supposed to be live footage of Apollo 11 as it was starting to orbit the moon when it first arrived there. And so I'll read this. A live broadcast of the Apollo 11 spacecraft allegedly orbiting the moon for the first time. The craft's movement shown here is nothing like the completely smooth, unidirectional motion of the craft in the preceding videos, where things on the ground very quickly moved out of view. Imagine a rifle bullet with a tiny camera on it. And as a matter of fact, the Apollo 11 spacecraft was supposedly orbiting the moon at twice the speed of a rifle bullet. And here's Frank Reynolds and his sidekick analyzing and commentating on what's going on. And I'm going to run through just 3 frames quickly. And these, like the others, are all 5-second intervals to show you a couple things. First of all, look at the quality of this video. It's ridiculous. Why couldn't they show you clear pictures, something like these, from the lunar orbiter spacecraft, or one of the lunar orbiters, which orbited the moon and took photographs before Apollo? Secondly, I want to orient you. This is Haldane crater here, and this is Schubert and Bach. Okay, these are going to be the craters we're going to focus on at first. Haldane, Schubert, and Bach. Okay, so now let's watch what happens. There's Haldane, a very unique looking crater. And here's the larger scene. There's Haldane, Schubert, and Bach, and then they're going to move from top to bottom here, which is actually from east to west. Okay. All right, finally, let's go through the scene. Now notice how erratic the motion is. They're zooming in and out, so that confuses things even more. But what I want to really point out is how long those two craters, Schubert and Bach, these two craters here, were in this field of view. They were in that field of view for 3 minutes. Okay, I'll speed up to get to the beginning again, and we'll see. I'll show you again. Okay, here's the first frame where Schubert and Bach are clearly in the scene, in the field of view. Okay, the field of view is simply the distance across this window that they're looking through. Okay, so there's Schubert and Bach at the bottom, and they're going to stay there. They're going to skip over to Haldane, going in the wrong direction, by the way. But when they come back down, they're still over Schubert and Bach. There's Schubert and Bach near the top there. There it is in the middle again, going back to the top. Finally, they leave Schubert and Bach. And this is an impossibility, because they couldn't have hung around over those two craters for 3 minutes. Here's Schubert and Bach, and together they're 60 miles in length. From both of them together are 60 miles in length. The field of view is only twice that distance, which is 120 miles. Schubert and Bach are 60 miles. Okay, and the orbital speed is 1 mile per second. Okay, 3,600 miles per hour, which works out to 1 mile per second. So that field of view that they were looking at should have and would have been covered in 120 seconds. Okay, 2 minutes. Instead, and you can go back and look at the times, but I've already done that, they covered it in 180 seconds. They took a full minute too long to cover that ground. And compare the length of time for any given object in the same field of view for the space shuttle, 30 seconds. Selene, 20 seconds. Apollo 10, 10 seconds. Okay, so here's an illustration of what's happening. The field of view is 120 miles. Okay, we can measure that. I did measure that. So in and because the speed is 1 mile per second, in 120 seconds, they've gone 120 miles, and they're looking at an entirely new field of view with an entirely new set of objects. There should be nothing if this is the second field of view, there would be nothing in it. They would have been from the first field of view, I'm sorry. Okay, an entirely new field of view. They went not only 120 seconds, they went 180 seconds. They would have moved 180 miles. All right, so they would have left whatever was here at first in the field of view they would have left it a long time ago. All right, Schubert and Bach would no longer be in the field of view after 120 seconds, much less 180 seconds. The spacecraft stays over crater Schubert and Bach, moving only very gradually for 3 minutes, an impossibility given what should be its extremely fast and constant orbital motion. In reality, the two craters would have disappeared from the field of view much sooner, after 2 minutes. Continuing, the spacecraft then sits completely motionless, an even more flagrant impossibility, directly over another crater, starting at this time here, an hour, 13 minutes, 30 seconds, for a minute and a half. Overall, the spacecraft's motion is ridiculously erratic, both in speed and direction. Clearly not orbital motion at all. So we're going to continue, okay, and now we're going to be over these 3 craters here, or this set of craters. Okay, that's going to be what's prominent in the field now. All right, so here we were, or they were, Schubert and Bach were at the bottom of the field of view. They moved to the top of the field of view because they're moving, now the spacecraft is over here, and now it's going to be over these 3 craters, and it's going to continue moving west. So watch what happens here. They sit over that crater for a while. Now watch this crater right here. Okay, it's going to move into the center of the field of view, and watch what happens after that. There it is in the center of the field of view. It stays in the center of the field of view for a minute and a half. It doesn't move at all. In other words, the Apollo 11 spacecraft is not moving until finally they leave. They hovered over that crater, which is a complete impossibility because there is no hovering in orbit. It's like a rock flying around the moon. It's literally, that's what an orbit is. Okay, and they had no technology to be hovering over the moon. They were showing us, what they were showing us was filming of a model. They were not orbiting the moon, period. Okay, moving on to the moon environment. And first we want to consider that the moon sits in an almost perfect vacuum. And I want to make this note. One of the keys to pulling off this deception by NASA is that the moon is a vastly distant alien place, totally inaccessible to non-astronauts. The perfect place about which to concoct a fairy tale. And for us, this is the key to unraveling the deception. To test NASA's story, we have to start not with the bogus material they provide us, but with our known Earth experience, as well as what we already know about the moon from solid scientific and astronomical knowledge independent of Apollo. So we're going to start with Earth. That's going to be our, our ground, so we know what reality is like. And this is a four-wheel drive car, Subaru, in fact. And what this video shows is, I'm going to just show you frames from the video, is rocks being sprayed in an arc away from the tire. And the interesting thing is that the rocks trace a shallow arc straight back. And in the video, especially, but also here, you can see individual rocks like that one right there, okay, move back in this shallow arc. And not many rocks get above the height of this tire, or certainly not this quarter panel. A few end up, up around here, but that's because they collide with each other. But otherwise, almost all go straight back. And this rear tire, as you can see there, is shooting rocks as well, independently of the front tire, and that's how they go. So the arc that they were tracing is similar to this one here, maybe a little higher. And these are all parabolic arcs. The only difference is the amplitude, the height and the distance. So I'll just read this here. Projectile motion is a form of motion experienced by an object or particle, in other words a projectile, that is thrown near the Earth's surface and moves along a curved path under the action of gravity only. In particular, the effects of air resistance are assumed to be negligible. This curved path was shown by Galileo to be a parabola. The study of such motions is called ballistics, and such a trajectory is a ballistic trajectory. And here is this trajectory traced by this water, this stream of water. And the typical, or I should say the prototypical example is a cannonball, because a cannonball is so massive that the air resistance is going to be negligible, because what we're talking about is the relative mass of the cannonball and the air. There's a large difference. So this is the parabolic trajectory that we're talking about. Now watch what happens with the sand here on this beach and with this dune buggy, the sand particles as they're shot from under this tire here. This is something completely different. They are not tracing paths, trajectories straight back like the rocks did. And that's because the sand is much lighter. So relative to the air, they have much less mass. And therefore they encounter very significant air resistance. And they bunch up here. The lead sand particles are slowed down by the air. They run into a wall of air all around the tire. And then the particles following the lead ones collide with them and bunch up. Okay? And that's why you get this concentration. But they still have energy, kinetic energy, and so they hit each other and they have to go somewhere, they go up. Okay? And this is, in fact, is a classic, or both of these are classic rooster tails. These guys that do these things, play around with these dune buggies and such, that's what they call them, rooster tails. Here you see, as this dune buggy moves, that it shoots up numerous rooster tails, vertical columns of sand. And the sand sits up in the air, in dust clouds, and then just settles gradually down, back, almost straight back down. In this video, you see even more closely what happens right from the beginning. The sand particles run into literally a wall of air. It's like a viscous fluid of air around them, around the tire. And so they don't go straight back at all. They form these classic rooster tails vertically, like so. And here you see the multiple columns of sand, in this case with this motorcycle, and the sand dissipates suspended in the air, and then settles gradually straight back down pretty much. So these trajectories are very different. They're trajectories with linear air resistance. They're not parabolic trajectories. They're not symmetrical at all. Not like that. Okay, so let's compare this lunar rover on the moon with what we just saw with that dune buggy on Earth. Okay, this should be very different, of course, because they're in a vacuum. And by the way, this particular scene is from Apollo 16. They were racing around and showing off what they could do with the lunar rover. So here we go. And what you see is nothing more or less than the exact same phenomenon. Okay, it's not, the parameters again are going to be different. The height of the particles, the exact quote unquote specification, so to speak, but the overall phenomenon is the same. A rooster tail, a vertical column of sand, suspended. It becomes suspended in the air and settles down very gradually. It is not, these particles are not exhibiting shallow trajectories, parabolic arcs at all. And here you see the classic arc of a forming rooster tail, and there it goes, gets bigger, and then settles down. The dust settles down gradually. And here's the multiple columns of sand in multiple rooster tails. And there's another example of a nice big rooster tail. It's the exact same general phenomenon of how sand particles, because they're in sand, fine sand, how sand particles behave in an atmosphere, okay, in air. They were not on the moon. The behavior of the sand or dust in the case of the lunar rover is essentially identical to that of the dune buggy on Earth, complete with prominent vertical rooster tails. But this would not be so if the lunar rover were really on the moon. The particles would, despite their low mass, instead shoot straight back in low parabolic arcs like the rocks of the four-wheel drive car, since they are launched from a similarly low point on the tires. In a vacuum, the mass of a projectile is irrelevant to the basic shape of its trajectory. All projectiles move in symmetrical parabolic arcs, since there is no air to offer resistance to their motion and cause their trajectories to deviate in any way. Without question, the lunar rover, quote-unquote, is being driven on Earth. Okay, moving on to gravity. The Earth is much larger than the Moon. This is something that probably a lot of people don't quite recognize, because we look up in the sky and we see a large moon, or what we imagine is a very large moon, especially near the horizon. And also in the sky, the moon is the same size as the sun, which we know is huge. So we imagine that the Earth would look more or less the same, but in fact the Earth would appear much larger, because in fact the Earth is much larger than the moon. And the mass difference is huge. The Earth is 81 times more massive than the moon, or in other words, the moon is only 1.2% of the mass of the Earth. And this translates into a moon gravity of only 1/6 that of the Earth. And here is the difference in size, graphically illustrated. It's like a basketball to a tennis ball. Whereas a basketball is less dense than a tennis ball, the Earth is actually more dense than the moon, because the Earth has a solid iron core, whereas the moon is just rock throughout. So the average person on Earth, especially a young, fit person, can easily jump 1.5 feet or 2 straight up on the Earth, like so. And here's this chart which shows that the average man, or the average jump of an average man, is 1.5 feet. And professional athletes can jump quite a lot higher than that. In fact, they can jump over 3 feet straight up. Now here's an average man. We're going to take this person as an average man, probably about 180 pounds. This is that actor, by the way. I forget his name. He did James Bond movies, I believe. But anyway, Now, how much would he weigh on the moon? If he weighs 180 pounds on Earth, he would weigh 30 pounds on the moon, 1/6 of that. And that's equivalent to a 5-year-old boy. Okay? So he weighs 30 pounds on the moon, but he has the body of a 180-pound person, a strong man. So he would be able to jump 6 times as high because he's only carrying 1/6 the weight he would carry on Earth. So 6 times 1.5 feet that he could jump on Earth would be 9 feet. He would be able to jump 9 feet. Now, how high would an astronaut be able to jump on the moon carrying a heavy backpack? Okay, now this backpack weighs about 120 pounds. So now a 180-pound man weighs 300 pounds, and all the astronauts were roughly average height and weight. So you're carrying 300 pounds, but it only weighs on the moon 50 pounds because you divide 300 by 6, which is the weight of an average 7-year-old boy. So you have a 180-pound man, strong man, carrying only 50 pounds. He should be able to jump about 4 times what he jumps on Earth. Okay? So he should be able to jump over roughly 6 feet. He should be able to jump like this. And by the way, that photograph that I showed you, this whole scene, this whole sequence, is from John Young's famous jump salute in Apollo 16. Okay, so he was demonstrating, maybe not explicitly, but implicitly, the low gravity on the moon. But he failed entirely because this is how high he should have been able to jump. Okay, it should have been very dramatic, completely unmistakable that he was in low gravity. Now watch the actual jump. That's as high as he got. He jumped a normal 1.5 feet. In other words, he was on Earth. He was definitely not on the moon because he definitely would have jumped much higher on the moon. In Wernher von Braun's book, Conquest of the Moon, which by the way is a much more realistic depiction of what a real moon voyage would be like than Apollo, this is what he said. Our movements are restricted by the cumbersome suits, yet we will feel light. The moon's gravity is 1/6 that of the Earth, so a 180-pound man weighs only 30 pounds. We will wear weighted shoes to help pin us down. They would need to have weights to hold them down, otherwise they would go too far and too high. But look at the jumps on the Earth. Here's another one. The guy jumps a normal height. Did I say Earth? On the moon, yeah. He's supposed to be on the moon, okay? But he jumps the height of what the same height as he would on Earth, more or less. That is not an abnormally high jump by any stretch. And you can see the same thing when they're walking and running as well. So here you see this astronaut hopping along. They do this little hop to make it look a little bit unusual, but clearly, and I'll run it backwards, or run it back and we can see it again, his feet do not get up high. They are just inches above the ground, okay, which would not be the case on the moon. It is the case on Earth, but it would not be the case on the moon. So here's what Gerard Wisniewski says, explaining what's going on. With less gravity on the moon, the strides would above all gain in height and length, and they do not. The strides are slower without becoming higher or longer. This would suggest that the photos were shown in slow motion. When speeded up, they immediately begin to look natural, in other words, earthly. So in some of these videos, like this one here, What Happened on the Moon, they actually go through the famous jump salute and other sequences, but they show them at normal speed. And they speed up the obviously slowed down moon film, and then they run that, and it appears completely normal. I'm not going to show you the video sequence, but jumps become completely normal, as do the runs, okay? In this video here, you can see these guys running after they've speeded up the film, and they look perfectly normal. And this is what must have been done. Because if they had been on the moon, and you had speeded up the footage of them on the moon, it would have been even more abnormal. Okay, at normal speed on the moon, they would have been jumping way higher and way farther than on Earth. And if you speeded it up, they would have looked like Superman. They would have looked like they were flying above the surface of the moon. Instead, when you speeded it up, they looked like they were on Earth completely. So slow motion was the key. It gave them a bouncy, floaty feel, or at least it looked that way. And this was the key to the illusion. So this is the kind of thing that we saw on TV. And I'm just going to show frames from the film. It looks slow and floaty. Okay, this is what it would look like at normal speed. Okay, it would look completely like a normal jump. That's the same basic sequence, except that I used a whole lot of frames in this one. Okay, and then I used a few frames to simulate simply a faster speed in this one. Okay, that's all it was. It was just playing with the speed of the film. Neither of these jumps is an abnormal jump at all. It's an earthly jump. All indications are that these astronauts, these so-called astronauts, were in Earth gravity, not moon gravity. And they had a few other alleged demonstrations of low gravity. At one point they hit a golf ball, supposedly, except that they didn't show where the golf ball went because the camera was fixed on the lunar rover and didn't follow the ball. The astronauts said, oh, it went miles and miles, but we didn't see that. They did the drop of a hammer and a feather, one in each hand. But that demonstration has been reproduced on Earth. It depends on the density of the feather. I did that experiment myself. If you have a fluffy feather, it'll drop slower than a hammer. If you get a dense feather, it'll drop the same speed as a hammer. And who knows that they didn't use a plastic feather, for all we know. Okay, so that doesn't demonstrate anything. And then at another point, they threw a hammer, this small hammer that they use for their geological work. They threw that, or one of the astronauts threw that, but from all appearances it looked like a 30 to 50 meter throw, which would have been perfectly normal in Earth gravity. It did not go hundreds of meters, which is what we would have expected on the moon. So the point is that they definitely were not on the moon. They were not in moon gravity. Radiation. These are aurorae. That's plural for aurora, also known as northern lights, except that they also occur at the South Pole. And they're very beautiful. If you've ever seen a good display, you won't forget it. And what it is energetic particles, radioactive particles, coming from the sun and hitting the Earth's atmosphere. So they demonstrate that radiation, space radiation, is a reality. There's no question whatsoever about it. And the first confirmation of this was in 1958, I believe, when the Explorer satellite went up, this satellite here, and it carried a Geiger counter. I believe that's how you pronounce that, Geiger counter, which measures radiation. And the radiation was so strong that it knocked out the counter. The gauge went off scale. And Ernie Ray, one of the scientists involved with this Explorer launch, said, my God, space is radioactive. And indeed it is. So there are three types of space radiation. There are particles trapped in Earth's magnetic field, there's solar particle events, and there's galactic cosmic rays. And this is a more colorful illustration of this. These are the galactic rays, this is the Van Allen belts, which I'll explain in a second, and this is the solar particles coming from the sun. So galactic cosmic radiation. Distant supernova explosions are thought to be the source of these high-energy ions. They travel across the galaxy at close to the speed of light and can easily pass through the walls of a spaceship. With current technology at least, they cannot be shielded against. Trapped radiation. Earth's magnetic field can trap charged particles from the solar wind. They become confined to the Van Allen belts, two donut-shaped magnetic rings encircling the planet. This type of radiation does not pose a threat unless astronauts travel through the magnetic field, but they in fact have to. Solar energetic particles. These high-energy particles are released by the sun during periods of intense activity known as solar particle events. Although these events are hard to predict, astronauts and vulnerable equipment can be protected from this form of radiation using shielding materials. This kind of shielding, though, is extremely massive, or would be massive. That's why it's never used. So this whole business of protecting astronauts, shielding material, is completely theoretical. In practice, it's impossible. And Apollo had no such shielding. So this is the Van Allen belts. There's an inner belt close to the Earth. Okay, that one right there. And the outer belt. Now, another indication of the reality of the Van Allen belts and space radiation in general is that we actually encounter it. Earth satellites actually encounter it
at the South Atlantic anomaly, this point right here. And the reason is that the Van Allen belts are asymmetrically distributed around the Earth, and that's because the magnetic axis is off center. Okay, it's not the same as the rotational axis. So because of that, one of the spots of the inner belt comes very close to the Earth. In fact, it's called the South Atlantic anomaly because it's right there in the South Atlantic and over Brazil, and this is a more dramatic illustration of that. Closest radiation belt to Earth roams above South America. It is called the South Atlantic anomaly and gives off high levels of radiation that has been known to destroy satellites. And these are some of the satellites it's destroyed: the Terra satellite, the Nozomi satellite, the CSAT satellite, and the Yamal satellite. Okay? And it's done other damage to other space vehicles as well. Now, moving on to the solar particles. This is a prominence. Okay? This kind of thing happens during the sun's magnetic storms. And these storms happen on a cycle, an 11-year cycle. They intensify over a period of 11 years. Now, this, as I said, is just a prominence. That's not the actual particles that fly all the way to the Earth. You can't see those. They're just atomic-sized particles. And this is a graphic illustration of the size of these storms. This is the Earth to scale. Okay, the storms themselves are much larger than the Earth. So a huge number of particles travel from the Sun to the Earth. However, we are protected from these solar particles by our magnetosphere. Okay, this is practically a force field, literally, that shields us from the oncoming dangerous particles. Now, the Van Allen belts are much closer to the Earth, and they don't shield us, but we aren't bothered by them as long as we don't travel through them. So we're protected in this cocoon of ours. And as I said, the storms follow a cycle. It's also known as the sunspot cycle or the solar cycle. And it's an 11-year cycle, and one of those peaks was right at the Apollo missions, the Apollo moon landing missions. So the astronauts would have been, if they had actually gone, would have been subjected to thousands of solar flares. Here are the numbers here. During 1968, 69, 70, 71, 72, thousands of solar flares. Now, the flares vary in intensity, but some of them are and would have been deadly to the astronauts. They received, on average, about 150 flares, or they experienced an average of 150 flares each on each mission. As again, some of those would have been deadly for sure. As John Malden says, and I'm going to quote from a few books here, and notice the dates. Okay, this is all long after Apollo. So this problem of radiation persists. Apollo did not solve it. So John Malden says, cosmic particles are dangerous and require at least 2 meters of solid shielding around all living organisms. Solar flares can give doses of hundreds to thousands of rem over a few hours. Such doses are fatal and millions of times greater than the permitted dose. Neil Commons says, you will face much, much more radiation in space than you do on Earth. Galactic cosmic rays will continually bombard your body and cause cellular damage. Solar energetic particles cause serious illness and death. Van Allen belt particles cause irreparable damage to living tissue. No reasonable quantity of known material will stop all these rays. This person, Leon T. Miroshnichenko, says solar storm shelters, that is, special thick-walled rooms, will be necessary both on the transit spacecraft and on the planet's surface. But the design of radiation shielding for a spacecraft is very difficult. The more realistic accounts of a future voyage outside of Earth's protective cocoon all talk about these storm shelters. But they would be, this is a vast understatement. They wouldn't be just very difficult. With no technology, they are impossible. They would be very massive, and you wouldn't be able to get a ship off the surface of the Earth with the required thick walls of a storm shelter. Yet that's what would be necessary both on the bodies that they would visit, like the moon, as well as in transit. So the whole thing, with our technology, space travel is an impossibility, period. Now, von Braun, more realistically, what he says that his astronauts would do not his astronauts of course, but what astronauts would do when they get to the moon is immediately get into shelter, okay, into a large crevice where they would be able to build their bases, and they would be protected both from the radiation as well as micrometeorites. Compare that practical, sensible practice with the Apollo astronauts who saunter around, prance around the moon without a care and completely exposed to both deadly radiation and deadly micrometeorites. Never was any kind of problem reported by the Apollo astronauts. Another indication of the unreality of Apollo is that the Soviets were always ahead in the space race. And here's a long list of firsts. They had the first satellite, the first spacecraft to the moon, okay, the first man in space, of course, first spacewalk, etc., etc., etc. So why didn't they reach the moon before the Americans? In 1963, Soviet space scientists told the famous British astronomer Bernard Lovell, in connection with their lack of plans for a lunar landing, that they, quote, could see no immediate way of protecting cosmonauts from the lethal effects of solar radiation. Viktor Bazykhin, a Soviet astronomer, says the information obtained with the aid of Sputniks, rockets, and balloon probes has proved beyond all doubt that radiation is the chief obstacle to penetration of cosmic space. The National Research Council, okay, in 2008, this is what they wrote: exposure to the space radiation environment outside of the protective magnetic field of Earth presents a risk with which humans have limited practical experience. What on earth are they talking about? What about Apollo? There was hardly any mention of it. Having a vexing discussion about the conundrum of space radiation today is like worrying in the 16th century about how to sail across the ocean to another continent when the voyage had already been completed numerous times and mastered by Columbus and others in the 15th century. It's absurd. If Apollo had been real, the radiation issue would have had to be resolved then. The problem still exists now because it was never tackled, and this of course is because Apollo was a fairy tale. Here are some damages to the body caused by space radiation: cataracts and damage to the eye, increased cancer risk, damage to the circulatory system. I'm not going to go through all of them, and this isn't even a complete list here. Skin damage, damage to muscles, cartilage, etc., etc. And why is this? It's very simple: because radiation kills cells. All right? Cell death, dead cells, and it breaks down the body. Yet these 12 astronauts are supposed to have walked on the moon, and 12 others are supposed to have made the trip, and even though they didn't walk on the moon, they would have been subjected to about the same amount of radiation, and all of them lived normal lives without any effects of radiation either during the trip or immediately afterward. No radiation illness or anything of the sort. In fact, they all have lived, almost all have lived long and healthy lives. The average age at this point in time is 80, and more than half of them are still alive. So there's no indication whatsoever that they had any encounter with any space radiation, and that's because they didn't go anywhere. Okay, now we're going to look at a topic, a subtopic of this Apollo hoax that few investigators, if any, have looked at carefully, and that is the surface of the moon as depicted in the Apollo photographs compared to how we know it is and has to be. And we're going to start first on Earth with meteor showers. These are periodic bombardments of the Earth by small particles, and this phenomenon occurs when the Earth in its orbit around the Sun plows through the old orbits of comets, mostly comets, a couple of asteroids as well. And in these old comet orbits, and when I say old, I don't mean the comet itself is old, but the debris from the comet has been sitting here for as long as the comet has been going around, okay? So the Earth plows through these comet trails where there's all this debris, and it's not just dust. I like this depiction because it gives you an idea of the number of particles, which is a vast number, but it's not dust at all, at least not mostly. The particles are pebble-sized mostly, and they get up to the size of baseballs, softballs, and that kind of size. They're not usually very large, but they can be sizable. Now, there are about a dozen regular periodic meteor showers, yearly meteor showers that is, and in tables like these we are told the length of the shower and, most critically, the number of particles that we can expect to see hitting the Earth's atmosphere. And this is the zenithal hourly rate, and this is one such. And so as the Earth goes through the path of the comet, the number of particles increases, that we hit increases to a peak. All right, but that peak, what's shown here, these tables show the peak, but of course we're not always at that peak. So to get an idea of the number of meteorites that we're encountering, we're going to take half of that peak, and we're going to take half of this duration of the shower to get an estimate of the number of particles that we're talking about. But before I do that calculation, I want to make this important note. The meteor counts given here are used because they are readily available, not because they are definitive. In fact, they are undoubtedly a vast underestimate of all the meteorites that strike the Earth and the Moon. In the case of meteor showers, this is because the zenithal hourly rate represents only the number of meteors a given observer can be expected to see from any one location on Earth, not a literal count of all the individual meteorites striking the entire planet at any given time, which of course would be an incomparably larger figure. In the case of bolides, which I'll describe in a minute, it cannot by any means be assumed that the instruments used to record the bolide strikes actually succeeded in detecting all the strikes in the given period. They most probably did not. Okay, so here we go with this calculation. As I said, we're going to take half the days. We're going to use that table that we just saw, and we're going to take half the days and half of the ZHR, and we just multiply, simple arithmetic, and we get this total for the year. Okay, about 67,000 meteorites from the meteor showers. But that doesn't include the sporadic or background meteorites, okay, which occur regardless of the showers. There's a constant bombardment, independent of the showers, which is roughly 5 meteorites per hour. So you multiply that by 24 hours, 365 days a year, and you get this figure. So the total altogether comes out to 111,000 and plus, okay, meteorite strikes from meteor showers per year. Now, the life of the Moon is over 4 billion years, and I'll explain that a little better in a second. But what we're looking at, what we're seeking to find, is the number of meteorite strikes that the Moon has suffered. Now, the Moon and the Earth obviously orbit the Sun together, so we can get a good idea of that number from the meteor strikes that we observe on Earth. Okay, going now to the Moon. As we said, 445 quadrillion strikes over 4 billion years, okay, and the surface area of the Moon is 38 quadrillion square meters. So you divide that number by that number, and you get 12 meteorite strikes per square meter of the Moon's surface. Now, as I said earlier, most of the meteorites are the size of large grains of sand to pebbles, but some of them are about the size of a baseball or a softball or even larger. A softball-sized meteorite would be about 4 inches wide, and when those objects strike, when any object strikes the Moon, it leaves a crater about 10 times the size of the object itself, diameter-wise. So a 4-inch diameter meteorite, which would leave a crater about 40 inches in diameter, which will cover the entire square meter that we're talking about here. Okay, so these figures already tell us that the Moon is completely covered by craters, at least small craters. This is a post-production editorial note. I made a couple of mistakes in my calculations in the original video. So now this number is different, this number is different, this one, and this number is slightly larger. The yearly total for the meteorites from the meteor showers. More significantly, and also this number is different, but as I was saying, more significantly, I skipped trillions and went straight to quadrillions for some strange reason which I could explain, but you don't want to hear my excuses. This is 474 trillion. It's not quadrillion. And here we have trillions and trillions, not quadrillions. Okay, but luckily for me, since I made the same mistake in both places here, the division turns out to be roughly the same. The figure from the division turns out to be roughly the same, 12 meteorite strikes per square meter. I might as well take this opportunity to make something else more clear than I did before, and that is that the moon, being smaller than the Earth, obviously gets hit by fewer meteorites because it presents a smaller surface to the oncoming shower that hits both the Earth and the moon. Now, these figures are all based on the Earth, which again is much larger, so they aren't strictly accurate for the moon. However, as I did explain, all of these figures are vast underestimates even for the Earth, so that would tend to compensate for the fact that the moon is smaller and gets hit by fewer meteorites. In any case, all of these calculations and all these figures are just aimed at getting a broad idea, ballpark figure for how many meteorite strikes we can expect the moon to receive. There's no pretense of exactitude here. Now, so far we've been talking about meteor showers, and that's not even half the story, because there are bolides, which are large objects. They're in fact small asteroids, and now we're talking about meters in size, okay, up to many meters in size. This is the largest bolide strike of the Earth in the past 100 years. It's the Chelyabinsk meteor over Russia. And this is such a cool video that I'm going to show it to you. Now, this meteorite came in and it was detected through numerous dash cams, in this case, and other photographic records. And here it comes. And there it goes. Now, I'll run through it again a little slower because it's so cool. It takes a while to get over this point, and then it explodes right there. Okay, and then the remaining fragments continue. That's the main one, and then there are trailing ones. And the trailing ones are burning, and the main one keeps on going. As I said, there were a number of recordings of this strike, which is one of the greatest astronomical phenomena we've seen. This occurred in 2015. Now, there was hardly any damage to the Earth's surface from this meteorite, which was about 20 meters in diameter. It broke up, as we saw, it exploded, and a number of chunks hit the Earth, but this was the largest right here. It just hit a lake and went down to the bottom, and they recovered a couple of the largest pieces. This was the largest piece here. I think that weighs about over 1,000 pounds, something like that. The important point for our purposes is that this bolide didn't even damage the Earth significantly. It caused a lot of explosions, windows bursting and that kind of thing. And so it did injure a number of people, but it didn't leave a lasting crater or anything like that. So this is a very significant point. The fate of A, meteors, and B, craters on Earth. Because of our thick atmosphere, most meteors are destroyed or at least drastically slowed down, therefore few craters result. Surface alteration, that is erosion and geological activity. Because of this, on Earth, craters are erased relatively quickly. We're talking about plate tectonics, volcanism, erosion from wind and rain, water, all that kind of thing. Okay. Now, the fate of A, meteors, and B, craters on the moon. Because the moon has no atmosphere, all meteorites hit at full speed and with full force, and all meteorites produce craters. There's no weather or geological activity on the moon, therefore there's no significant erosion. Craters remain forever. These are the bolides that hit Earth during this period, a 20-year period, as recorded by U.S. military installations of some kind. The articles didn't explain. But anyway, the number is what's significant here, and these are bolides in the 1 to 20 meter diameter range. Okay, 556 over that 20-year period. So you multiply these two figures and you get about 110 billion meteorite strikes, bolide strikes that is, in 4 billion years. And you divide that figure by the by the surface area of the moon, which we saw earlier, okay, and you get 2,900 strikes per square kilometer. Now, let's take the average impactor, the average bolide, as 4 meters in diameter. As I said, by definition, the bolides that we're dealing with are 1 to 20 meters in diameter, and of course they can be larger than that. But anyway, conservatively we take a 4 meter impactor as the average. That gives us a 40 meter crater, and that's this area right here, and you multiply that by 2900 and you get a surface area of 3,600,000 square meters. Okay, but we're talking about the number of strikes per square kilometer. So we get this figure and a square size of the craters collectively on the surface of the moon, and that's over each square kilometer, which is only 1,000,000 square meters. So 3,600,000 divided by 1,000,000 is 3.6 square kilometers of crater area per square kilometer of moon surface. In other words, the moon is covered many times over by craters, by not only the meteor shower craters that we saw earlier, which would be mostly small craters, but these larger craters as well. The moon is literally covered by craters, many times over, as a matter of fact. And scientists know this, astronomers know this about with regard to the highlands, okay, where you see in photographs all these craters. Now, what I'm going to argue is that the Maria are also, the lowlands are also covered by innumerable craters. Okay, so to think that the Maria are smooth and craterless is actually a misconception. We get the best idea of how blasted the moon is by craters when we look at the far side of the moon, the side that's always facing away from the Earth. It is totally covered in craters everywhere, and craters on top of craters. Okay, that shows you how blasted the moon is by meteorites. Now, the only reason that there are Maria without all those large craters is that after 500 million years of the life of the moon, also the life of the solar system, during that first 500 million years, there was this bombardment of the moon and all the solar system bodies by large impactors, by planetesimals, okay, small asteroids, planetesimals. And that went on for about 500 million years, and then all of those bodies flying around collected, they aggregated into the planets and moons that we know today. All right, so that bombardment ended after 500 million years, but toward the end of it, those large planetesimals pierced the moon's near side, and that's because the moon's near side has a thinner crust than the far side. They didn't pierce the far side crust. For reasons that I don't want to explain, the near side of the moon has a thinner crust. Okay, so lava, molten lava, rose out of the interior and covered these areas here, which is the Maria. All right. However, ever since then, and this is where the 4 billion years comes in, the moon has been bombarded by meteorites, as we saw, both meteor shower meteorites and bolides as well, just like the Earth, except that all the craters remain on the moon. So it's a misconception to think that the Maria regions are more or less free of craters. First of all, we can see that there are a number of craters in them, but we'll see more. And the moon has been bombarded ever since then, as we see in recent photographic and video records. This is a 1953 photograph of a meteorite strike. It was estimated that the impactor was 20 meters in diameter, and it left what is estimated to be a 200-meter wide crater that was found. This is a video from 2013, I believe, that shows meteorite strike. I'll show that again. That's a meteorite strike, caught on video. Here's another video, and for some strange reason, this institution had to paste these large logos all over the moon, but this is the moon, okay, and this is where the strike is going to be, and there it is. Okay, so this is also 2013. These two were from 2013. So the bombardment of the moon has gone on unimpeded ever since that late heavy bombardment, and that includes, of course, the Maria as well. So before we look at the Maria more specifically, let's look at some of these famous craters on the moon. This is the most famous of all, Tycho. It has this ejecta blanket. Okay, it's called an ejecta blanket. This material that was blasted out of Tycho when that meteorite struck. It also has crater rays, these things here, okay, which go as far as here as we can as far as we can tell, okay, literally hundreds and thousands of miles across the surface of the moon. And this is what one astronomer said about Tycho. As you gaze at the ray system, try to appreciate the force behind an impact that would scatter boulders more than 1,000 miles across the surface of the moon. It is popularly assumed that these rays have the texture of face powder and that an astronaut would have difficulty detecting them if he were standing in the middle. Such is not the case. The brighter rays are made up of ejected rubble that consists of crushed rock and boulders that are up to a couple of feet in diameter. Large rays are commonly several feet thick and would be difficult to walk through. Now this here, where he says that the boulders are up to a couple of feet in diameter, that's a vast understatement. And I'll explain that in just a little bit. But first I want to point out that this is Tycho here, all right? Now this is a composite image. It's not one photograph. We would never see the moon exactly like this. And I don't want to take time to explain why, but the point here is that Tycho is only one of many craters, innumerable craters, large craters. And all of these craters would have left ejecta blankets and crater rays and a whole lot of material all over around where they hit. The only reason that Tycho, the crater rays and ejecta blanket, are so conspicuous is that Tycho is younger than these others. So as you see here, Tycho's crater rays and ejecta blanket are conspicuous. Most others are not so conspicuous. Tycho crater is one of the youngest large craters on the moon, and it is for this reason alone that its ejecta blanket and crater rays are still prominent. Over time, these features fade in color and brightness due to both solar radiation and micrometeorite bombardment. All of the countless large meteorite impacts on the moon have spewed prodigious amounts of material in the form of boulders and rocks over large areas of the moon's surface, and this jumble of material remains there forever. Here are another three well-known craters on the moon. This is the most famous of these three, Copernicus, this is Kepler, this is Aristarchus. And these are these craters right here. And you see that their ejecta blankets and crater rays cover a large portion of this western Mare region. So look at that large ejecta blanket of Copernicus. And this is a little closer. And notice this string of craters. Those are not independent craters. Those are craters created by the objects blasted out of Copernicus when the meteorite created Copernicus. So imagine huge chunks, and we're talking, God knows how large these objects were, flying out of Copernicus, going up into space and coming back down and creating these craters here, the largest of which are 4 miles wide, this one right here and this one right here. Okay, and then the smaller ones are about 2 miles wide. That's what these are right here, these craters here. Those are not mostly, for the most part, are not independent craters. They're secondary craters from the blast that created Copernicus. That just shows you how much material and the size of the objects that we're talking about that are blasted out of craters, out of large craters. For comparison, this is Meteor Crater in Arizona, also called Barringer Crater, and it's the largest well-preserved crater on Earth, but it's only 3/4 of a mile wide. Going back to Copernicus, this is a closer view with higher resolution, and these craters here, okay, which would be a little closer to Copernicus here, but they're not well resolved, if at all, okay, those craters are on average about 1.5 miles wide. These innumerable craters, all right, you can even count them. 1.5 miles wide, that's still twice as wide as Meteor Crater. So that just shows you how much material is blasted out of a crater like Copernicus, which is not an extraordinarily large crater by moon standards. This is a small crater. This is Censorinus. It's only about 4 kilometers wide. And look at the boulders on the edge of this crater. Okay, you would think that it was smooth. There was nothing around it in this large-scale photograph. But if you look at it more closely, these larger boulders are about 150 meters wide. That's twice as wide as a tractor trailer, or about the size of a large very large apartment building, taking up a good amount of a city block. And of course there are a whole lot more boulders, house-sized and car-sized. Now let's get back to the Maria. They look fairly smooth, all right? But you can see that there are already here, you can see that there are craters in the Maria. So the Maria are not crater-free by any means, okay? You can see quite a number of craters already. But some areas look smooth, like take this here. This is sinus iridum, all right? It looks smooth, right? When we look more carefully with a higher resolution photograph, or in a higher resolution photograph, we see a number of craters, all right? This one right here is Laplace A, and it's 8 kilometers wide. So these two here are about 4 kilometers wide. But the closer you look, the more craters you see. Now we're going to look more closely even at this area right here, from there to here. This is a close-up from a more recent lunar orbiter. And what you see is really quite astounding. Innumerable craters. Not only well made out ones, the well resolved ones, but the ones at near the limit of resolution. You can see that there are literally countless craters, small craters. But again, look at how many small, barely resolved craters there are, just at the limit of resolution, or just below, as a matter of fact. Okay, they're innumerable. And here, this is an enlargement of this region right here. You can see very clearly all these craters coming into view, some of them barely. So the moon, including the Maria, are in fact covered by craters. Now this looks fairly smooth with just a couple of craters there. This is what it looks like in a closer view. These three craters right here are about 300 yards wide. Okay, and this crater right here is 100 yards wide. But there are, countless other craters in a jumble. Okay, all kinds of craters, small and large. And this is there's no reason to think that this part of this Maria is atypical. Right? This undoubtedly is what all the Maria on the moon are like, literally covered with craters. The Apollo landings were in various terrain, okay, in varied terrain. There were 6 of them, and the Apollo 11 and 12 were in Maria, 14 and 16 were in highlands, and 15 and 17 were at the edges of Maria, but surrounded by mountains, in mountain ranges. Okay, and yet, despite this variety, and despite what I showed you about the moon having to be covered in craters and boulders, these are the typical photographs that we see from the Apollo missions. This is Apollo 11. Where the craters and boulders? Apollo 12. Apollo 14. This is in the highlands, where you would definitely expect to see craters and boulders. Apollo 15. Apollo 16. Mega highlands. Apollo 17. Fake mountains. This is the general view that we get from Apollo of a featureless landscape, a lunar landscape without any significant craters or boulders at all. Literally just handfuls of decent-sized craters and boulders. It is totally unreal. Okay, now we're going to look at the individual missions, 4 of them. We're going to skip Apollo 11 and 12 because they were very boring. They landed in places where there was little geological features, so allegedly, okay. Now, any trip, any landing anywhere on the moon would have been, in reality, totally fascinating, but in these fictitious Apollo landings, 11 and 12, there was nothing to see, pretty much. Anyway, enough of that. So we're going to move on to 14, and then we're going to go to the next 3, 15, 16, and 17. Apollo 14 allegedly landed right there. It's right here, above Fra Mauro. This crater here is called Fra Mauro, and the landing site is right there. Fra Mauro here, the landing site right there. Okay? And here's a NASA image with the arrow on it, but the arrow is a little misplaced. It should be a little to the left. And here's Fra Mauro again, and this is the Fra Mauro Formation, I believe it's called. Yeah, Fra Mauro Formation. And you can already see how rough it is. And here it is again, and there is the landing site. Again, the arrow is a little off. It should be a little below that. Right there is the landing site. And they landed among mountains or hills and this ridge, okay, this very prominent ridge. And they did so intentionally. After Apollos 11 and 12, which were flat and allegedly boring, they went looking for a hilly region with ridges a few hundred feet high, all right? And that's exactly what they landed in. In this amateur photograph, and if I haven't said it already, we depend mostly on amateur photographs, even if they're not the highest quality, because we know that they're honest at least. In this photograph, here's the ridge that they landed next to. They landed about right here, okay, in the center of that arc of that ridge. And so here the ridge is in light, is in the sunlight. Here, there's the ridge, it's in shadow, okay, and they landed roughly around here, all right? About 1,000 meters from that ridge, by the way, or a little over 1,000 meters from that ridge. And in this mission, what they most specifically were going to explore, intending to explore, was Cone Crater, okay? This crater right here. Now, there are several reasons why I can say that this crater, this alleged crater, Cone Crater, it doesn't actually exist. It's doctored in, it's pasted in. And one reason is that they're going to claim that they couldn't find, they're going to go look for that crater and they're going to claim that they couldn't find it, which is preposterous. And I'll explain that as we go along. A second reason is that in the subsequent missions, 15, 16, and 17, they definitely doctored the landing sites. And we're going to see a whole lot of evidence of that when we get to those missions. Okay, now the third reason that we can say that this is doctored is because of the evidence from this photograph. As you see here already, but especially here in the close-up, these labels, all right, go to specific craters. These labels and these lines, arrows sort of, point to specific craters. This one is Old Nameless. This label and line point to this crater here, this somewhat flat crater above what they're claiming is Cone Crater, okay? And this landing site is precise. So that this label and arrow are precise, this is precise. Why is this so far off? Now, look at the difference in contrast between this crater and these two, and as a matter of fact, all the other craters on this in this image, but especially these two, which are about the same size. Look at the very large difference in contrast. The white is whiter, the dark is darker, all right? That thing here does not belong in this photograph. And now look at this. Look at this line, that sharp line, and this sharp line, especially on the top one, okay, which is seen nowhere else in this photograph. You can already see it there. All right, that is alien to this. Look at this crater compared to these two. All right, and also notice how the checkerboard or whatever checker pattern pervades the photograph and is inside all these craters. It is not in Cone Crater. This alleged crater is foreign to this photograph. It's pasted in. They use some 1970s or so version of Photoshop. Also, more evidence that that Cone Crater doesn't exist. It's not in this photograph. The only other old photograph, authentic looking photograph that I could find. The most authentic photographs of Apollo are the earliest ones, taken by, in fact, they're not even Apollo photographs. These are pre-Apollo photographs taken by lunar orbiters. So here you have Old Nameless and the landing site shown and labeled, okay, but there's no Cone Crater as there is here. Why would that be? Cone Crater should be right there. Right about there. This is about the same scale, okay? It's not there. So for all of these reasons, we can say almost definitively that Cone Crater doesn't exist.